Good morning, brothers. Let us start with the experiment resonance and low pass filter. Resonance and low pass filter. Okay. Uh, till now we have completed three experiments before shutdown. We have completed three experiments in the laboratory. Okay. First experiment was regarding the basic Kirchhoff voltage law, current law, and Ohm's law, equivalent resistance, whatever it was very basic. Okay. And the next experiment was regarding the theorems. We verified the theorems over there. Third experiment was AC part, where you work with the function generator, oscilloscope, with the AC part. Okay. So now we will take further. We will go further with the AC part, and just we will use function generator and CRO in this experiment. So due to some scenario, we didn't able to record the video, but I have done the video. I have just got the readings and the appropriate things for you. So inshallah it will be definitely helpful for you. Okay, these are the components what we are going to use. Okay, so part A, to examine the properties of simple series resonance circuit. So just we are going to study the properties of the resonance circuit, series resonance circuit. That means RLC component will be connected in series to determine the resonance frequency, F or not, or F resonance, what we are going to use, bandwidth and quality factor. So apparatus, as I told you, we are going to deal with the AC. That means AC means AC part in the function generator, voltage supply. Okay, and function generator we will use to provide the input voltage. Okay, so sinusoidal input voltage, resistor, capacitor, and the inductor, and the CRO to see the output. And this is the circuit diagram. Here this is the function generator. With the function generator we are using we are setting the input voltage V peak to peak to 5 volt. Okay, and here we are measuring VL across the across the inductor, across the capacitor, VC across the capacitor, and VR across the resistor. This is series RLC circuit. Okay, so here, as you know how we worked with the CRO in the last class. So CRO, this is cathode ray oscilloscope. This is the display. In this display you can find number of boxes. That is called the deflection coefficient. Okay, 1 2 3 4 5. So this is the 5 boxes into 1. This is how much? 5 into 1 becomes 5 volt peak to peak. Okay, this is 5 volt peak to peak. We set the input to 5 volt peak to peak. Then across the resistor we will just will set the frequency. Here it is 10 micro. Okay, you can change the frequency accordingly. Okay, it is not at the beginning, it is not a big deal. So when we start with the experiment, we will just take the output across the resistor VR peak to peak. Okay, VR peak to peak, you are taking VR peak to peak, not V RMS. If you want to connect, if you can connect these to the multimeter, then you will get RMS value, but we are not taking RMS. We will convert later on. Okay, so here we will just take the RMS peak to peak value with the help of CRO probe. Okay, in the part A, measurement and the calculation, change in the frequency. Okay, we start with the 2 kilohertz, increase till 16 kilohertz, and U peak to peak value, I told you, we set the value to 5 volt peak to peak, 5 volt peak to peak. Okay, and capacitor value is 47 nano, R is 100 ohm. To calculate, just after setting in the function generator, when you set 2 kilo, you will get on the CRO you will get the this values, VR peak to peak. You will get this value around this. Okay, when you change the frequency you will get these values. So VR is nothing but RMS value. We will convert V peak to RMS. That means V peak to peak by 0.35353. So you will get, with this you will get the RMS value. So current is VR by R is 100 here, because we are calculating across the resistor. If you want to calculate across capacitor, you just remove the probe, this probe, and connect it here. You will get across capacitor, but we are not interested with the capacitor. We are only interested with the resistor. Okay, So we are calculating across resistor. So I is VR by R, and that you can calculate. Okay, F resonance. What is F resonance? Resonance is F resonance is 1 by 2 pi root LC hertz. Okay, so 1 by 2 pi root LC. LC value you have, inductor and capacitor value is given here. Inductor value is in the apparatus. Okay, you can find capacitor is 47 and the inductor value is 5.7 millihenry. Okay, you can use and you can get the F resonance. Quality factor is omega naught into L by R, which is nothing but C into R. So C is how much? 47 nanofarad, and R is 100. Okay, so 2 omega naught is nothing but 2 pi F. Okay, F naught or F resonance already we calculated. From this you will get F omega naught, and from here you will get Q naught. Quality, you find the quality factor. Just plot the graph. This thing you can find in the manual, where you just draw it and submit to me. Okay, in the part B, low pass filter. Before starting with the low pass filter, you should be having a small idea about the low pass filter. Filter, what is first of all filter? Filter means where something is stop and something is sent, right? Filtering, that means here we are stopping some frequencies and sending some frequencies, low frequencies, high frequencies. So what is the meaning of low pass filter? Low pass means low frequencies are passed and high frequencies are stopped. Here low frequencies are stopped, low frequencies are passed. In high pass filter, low frequencies are stopped and high frequencies are passed. So how you decide the low and high frequencies? What is that where you select the point, that is called as the cut off frequency. So to get the idea of the cut off frequency, just we will see this figure. Okay, if this is a straight line, suppose this is a straight line, if this is a straight line, that is called as the ideal low pass filter. Ideal low pass filter, which is impractical, you cannot implement ideal filters because of its sharp edge. Okay, so this is the practical filter, where it is the fall time. Here it is 70% of the peak. 70% of the peak is 0.707, that means 3 dB. So this is the cutoff frequency. This means that we will have this point from till that point we will allow the frequencies. After that point we don't allow the frequency. That is called as the cutoff frequency. So here in this case we are going to construct a low pass filter according to the circuit diagram. Determine how you decide the low pass filter based upon the cutoff frequency. Okay, so these are some objectives, and voltage supply, function generator, resistor, these are the combination. So here, as in the previous case, we set the input voltage from the function generator, because from the function generator we will get sinusoidal input of 8 sine omega naught t. Suppose, okay, this is 8 sine omega naught t. What is omega naught? Depends upon the frequency what you are giving. Okay, so 8 volt peak to peak. Here the peak to peak value of the input is 8 volt. In the previous case we set it to 5. That means how much boxes it will be? 8 boxes into 1. So 8 volt peak to peak is your input. Okay, VR is, this is VR. Okay, this here you calculate the voltage across resistor, and this is output. From this point to this point it is output. Okay, so things are written here clearly for your understanding. Just have a look in this. Okay, resistor is 4.7, C is 4.7 nanofarad. Okay, so V peak to peak is 8 volt. So R peak to peak value is 8 volt. Okay, and now frequency we are going to set 100 hertz, 500 hertz, 1 kilo, 2, 3, 4, up till 14 kilohertz. So at this, when you change the frequency from the function generator, that means that button 0.1 kilohertz, when you set this value, you will get 8 volt in the CRO. Okay, in CRO you will get 8, 0.58. So here you can see it is at this point I am just mentioning cutoff frequency. Why cutoff? It is cutoff frequency because it is V peak to peak into 0.707. this is V peak to peak. What is V peak to peak here? V peak to peak is 8 volt into 0.707 becomes how much? 5.6. This is, at this point it becomes what? Cut off frequency. 5.7 is the cut off frequency here. So that means F resonance is 7 and V output is, this point is where the cutoff frequency you are getting this value exact to the cutoff frequency, so it is 5.6, and VR, that means R across the volt, across resistor, it is 8 volt. Okay, let us go to the next slide. Just I explain you. Okay, this is not ideal, this is practical practical low pass filter. In this case, now we have the resistor value 100 kilo ohm and capacitor 10 kilo ohm and 10 nanofarad. Just at this point you will get the cutoff frequency again, it is 5.6 here, right? So 5.6, F resonance is 1.5, VR peak to peak is 8 volt and V output is 5.6. So just draw this accordingly. Just have a look in the manual and submit it to me before Thursday 26/3/2020. Okay, before 12 noon. This is my email address. For any discussion, I am available online in the session. You can have a discussion. Thank you for listening.